Welcome to everyone. I am Chandan Kumar Sethi, Assistant Professor of Mechanical Engineering from Kalam Institute of Technology, Barampur, Odisha. Welcome to the section where we will discuss about the introduction to the heat exchanger. Before going to discuss about the heat exchanger, first we will know what is a heat exchanger process and how the heat transfer will be happen. We already know from the definition of heat transfer, the heat transfer is flow from a hotter body to a colder body, and heat exchanger is the application of heat transfer process. So when going to the heat exchanger, the definition of a heat exchanger is given by it is a equipment which is generally used to transfer the heat between one solid body to a fluid, or between the two fluids, or between more number of fluids. Because of the vital role of heat exchanger nowadays in every application process, because of the sustainability and the efficient of the object. Now we will go for the classifications and what are the different examples of heat exchanger. First come to the examples of heat exchanger. I can give you a simple example of heat exchanger where in the IC engines the general fluid which is used as a coolant, that is flow in the coils of a radiator and the air is blown over it so that the coolant will be cooled. Other types of heat exchangers can be divided. We can say the air cooler, pre-cooler, the automobile radiators, etc. Now come to the classification of heat exchanger. If we will classify the heat exchanger, we will see the different objects or different categories. First come to the first category, that is called as on the basis of nature of heat exchanger process. In this category, the heat exchanger is divided into two types. First is the direct heat exchanger, and one is indirect heat exchanger. In direct heat exchanger, the two fluids will be mixed with each other because of there is no separation wall. But in the indirect heat exchanger, there is a separate wall so that it will prevent the mixing of two fluids. Come to the second category, that is called as relative direction of heat flow. In this category, we have three types of heat exchanger. One is parallel flow, one is cross flow, and one is counter flow. So first come to the parallel flow heat exchanger. In the parallel flow heat exchanger, the two fluids which are used in the heat exchanger, we can say one is a hot fluid and second one is a cold fluid. The two fluids enter to the heat exchanger in a single way and comes out from the heat exchanger in the same way. That is called as a parallel flow heat exchanger. But in the counter flow heat exchanger, the direction of entering to the heat exchanger, the fluids have the different positions. But in the cross flow heat exchanger, all the fluids, means the two fluids or more number of fluids may be crossover to each other. That is called as cross flow heat exchanger. Come to the third category, that is called as design features. What is the requirement we have needed, that is the design feature. We can say one is a plate type heat exchanger where number of fluids and number of tubes are used, that is called as cell and tube heat exchanger. Now comes to the design of a heat exchanger. Before going to design of a heat exchanger, first we will see that what are the different parameters, what are the governing equations we are used so that we can calculate or we can design a heat exchanger. First, before going to obtain the equations, we know what are the governing parameters are used in the heat exchanger. First governing parameter is called as the overall heat transfer coefficient, or we can say that is capital U. Second one is the heat transfer rate, or we can say the surface area, that is capital A. Next come to the temperature difference. The temperature difference between the inlet temperature and the outlet temperature, or the inlet temperature of hot fluid to the outlet temperature of cold fluid. This is all about the heat transfer and heat exchanger processes. Now before conclude to the heat exchanger, we will see what are the parameters and what are the processes by which we can calculate or we can design the heat exchanger. We can design the heat exchanger by two processes. One is called as LMTD, that is called as log mean temperature difference, and second one is called as effectiveness, where we know the inlet and outlet temperatures. That time we can apply the LMTD method, but when the inlet and outlet temperature we have to calculate, that time we will use the effectiveness method. This is all about the heat transfer process and the heat exchanger. I hope you will all understand about the heat exchanger and its introduction. Thank you.